Okay. Now, the first of all, we will going to start from the charge. So charge, there are two types of charge. One is positive, another one is negative. The magnitude of the charge remains constant. Another thing, charge is quantized. Do you know what do you mean by quantized?
No, sir.
Okay, so quantized mean discrete. Do you know what do you mean by discrete?
The release?
No, it means it is always written in the integer form.
Oh, okay.
Okay, so the charge is always written in the integer form, like 2e can be possible, 3e can be possible, but it cannot be possible half. Like, for example, for example, that will be 1e possible, 2e can be possible, 3e can be possible, and so on. But 1 by 2e and 0.5e, these two examples are not possible. Okay,
Yes.
not possible. So it means there will be some formula for the charge. So the formula for the charge is Q is equal to NE, where Q is the total charge, E is a single charge value which is given in the formula sheet. Single charge, that is 1.6 into 10 raised to power minus 19. And what is N? N is called number density. Number density. It's fine. In some
Yeah.
MCQ, yeah, in some MCQ, it is written only number, but in some MCQ, they have written with the number density of the unit of per meter cube. Yeah, because its formula is N by L cube sometimes, especially in MCQs, okay? Especially in MCQs. Yeah, yeah,
Yes.
yeah. Ibrahim, do you want to say something?
Um, sir, the charge formula, this is N is number density and E is the charge of the electron.
Yeah, single charge value, not electron, okay? Not electron. This is the magnitude which can be electron or it can be positive charge, okay? Can be negative charge or it can be positive charge. Both can be possible, yeah.
Yeah, okay, sir.
And that's about the n. N is a basically number per unit volume. But I have seen the MCQ of 2311 paper, that where this n is written as number, okay, number. But I have seen the question of 2020 in 23, so sorry, not 2313, and where they have written with the number density. So be careful. This n is sometimes called charge carrier, okay?
Yes.
Sometimes called charge carrier. Whenever in MCQs they say charge carrier, so that is considered to be a number, not number density. When they use the word of charge carrier, then it means the small n is considered to be a number, not number density. Okay.
Yes.
Otherwise, if the value is given in per meter cube, that it means it is considered to be number density. Okay. So
Oh,
both way can be possible. Now, after that, the important point, what are the important points? I'm going to underline it. That charge is quantized and the main formula Q is equal to NE, which show the quantization of charge. It's fine. These are the two main points. Now coming toward the current. Do you know current? What is electric current? Yeah.
law of charge.
Yeah, rate of flow of charge. Complete definition, rate of flow of charges through cross-sectional area. But the acceptable definition is rate of flow of charges, okay? Or you can write flow of charge per unit time, okay? You can write like that. So from here, we can write the formula I is equal to Q by T. You have already studied in IGCS level, okay?
Yes.
But now it is not in the MCQ, it is using I is equal to NE divided by T. Remember that. They replace the Q with NE, okay? Sometimes the question will be given on this formula. It's fine.
Yes, sir.
So the unit of current is ampere. It is a base unit, so that's why it is a scalar quantity. So the current is a scalar quantity. It's fine.
Yes.
Now, in one of the MCQ, I have seen that they have give you the number per second. So they give you the number per second. What do you mean by number per second? They give you the n by t value, okay? And the e value is you will take from the formula sheet and then you will find the current. It's fine. So this is the hint can be come into the MCQ paper also. It's fine. Yeah.
Yeah. Yes, sir.
Okay. Now, after the current, we have another definition that is known as the most question which is coming in paper 2, drift velocity. Yeah. Do you know drift velocity? The most
Mm,
regular question is coming from this drift velocity. Yeah. Average velocity of an electron. It's fine.
average velocity of electron. Yes, sir.
Through conductor. The formula of drift velocity is Vd is equal to I divided by NEA. So this is the formula. This is given in the formula sheet, okay? But but in one paper they says prove, show that, show that. So means you prove that equation. Okay? That's fine. Now we are going to
Um,
prove the equation now. Okay? That's fine.
yes.
Now,
Yes.
so we know that I is equal to Q by T. So this is your equation 1. Now we know that Q divided by V volume, this V is volume is equal to NE. Or Q is equal to NE into V. Yeah, if you put this here, you get I is equal to NE into V divided by T. Yeah.
Okay, sir.
Any
Sir, for the
confusion?
second point,
Any
um,
confusion?
the second point, Q over.
Volume. Exactly. I'm expecting that you will ask the question. I left always that point that the student will ask me about that point. Okay. That's why I left. Okay. So I'm going to explain first this point. Okay. That you don't have the ambiguity. Now, can you tell me what I have written the unit of n, small n, here,
Meter cubed.
meter cube. Okay. Now, what is the unit of E?
Um,
Yeah,
Coulomb.
Coulomb. So on my right hand side, the unit is Coulomb per meter cube. It's fine. That is on the right hand side. It's fine. Now let's
Yes.
check the left hand side. Now Q is written in the first equation. Q is equal to Ne. What is the unit of Q? Coulomb. And you know
Uh,
that, yeah, and you know that the equation is homogeneous when left hand side and right hand side unit will be the same. That you have done
yes.
the practice in chapter number 1. So you need meter cube. So that's why you divided by volume. And the unit of volume is per meter cube. So that's why we written coulomb per meter cube on the right left hand side also. It's fine. This is the one
Yeah.
explanation. The second explanation. What I have written here, the definition of current. Can you completely read the definition?
Rate of flow of charge through cross-sectional area or flow.
Exactly. Through cross-sectional area. It means that wire has some length and it has some area. So it means this wire has some volume from where the charges are flowing. It's fine.
Yes.
So that's why that is written Q by V. Okay, it's fine now.
Yeah. Okay, sir.
Okay, okay. Now, can we write the last equation? Now, Ibrahim, you can ask any question, okay? Don't think anything, ask the question just, okay? So
Okay, sir.
I convert volume into A into L and I put the T on that side. It's fine. Now we know that V velocity is equal to distance divided by time, which is I written by L, okay? And the
Okay.
time is equal to length by V. So put it here, I get I L by V is equal to NEAL. So L will be cancel out well L and you get I by V drift velocity is equal to NEA. Or you can write drift velocity is equal to I divided by NEA. That's fine. So this is the proof. This equation will be written in your formula sheet like that. I is equal to NEA V drift velocity. Yeah.
Okay, sir.
Whenever in the paper, in MCQs especially or in subjective paper, they ask you to calculate the drift velocity, how you going to verify your answer? Remember that the drift velocity value vary from 10 raised to power minus 3 to 10 raised to power minus 5. Okay? So drift velocity is always between 10 raised to power minus 3 to 10 raised to power minus 5. Okay? So this verify whenever you calculate the value, this verify that your drift velocity is correct. It's fine.
Yes. Okay.
Okay. Have you noted this? You can take the screenshot also.
Okay, sir.
Okay. Now, coming toward the drift velocity again. Now this is equal to I is equal to NEA into VD. Now, in one question of paper 2, okay, I am talking about paper 2 now. In paper 2, they says, write the volume here. Have you understand the question? They says, write the drift velocity, not with area, write with the volume. Yeah.
Yeah.
Have you
Um.
understand the question?
So we change area into volume.
Okay, yeah. But how? Remember that again, what is a small n? Small n is the number per unit volume. That is the number density, as I told you. As I told you, this is number density. Remember that, okay? It's fine.
Yes.
So when you put it here, you get I divided by n over L cube EA. Now, what you get? VD is equal to IL cube divided by NEA. That's fine.
Yeah.
Yeah. So the area is cancelled out with this length, and you get VD is equal to IL divided by NE. Sorry, not with the volume, with length. Sorry, I just forget the question. So this is the answer. This is the proof that one. That write the value with length. It's fine.
Wavelength. Okay.
Yeah. In this, why they have says that prove this, show this. Why they says? Because in this question, they want to tell you that number is constant, E is constant, L is constant, and the drift velocity is proportional to I. It's fine. When your flow is increased, your drift velocity will also increase. Yeah.
Okay, sir.
Okay. So with this, the drift velocity, the drift velocity topic will be completed, and your first portion of electricity is also completed. Means electric
Yes.
current, charge is quantized, and the drift velocity. From these three topics, one MCQ is coming, okay, into your paper. There are total seven MCQs are coming from the electricity in CIE examination, okay? It's fine.
Yes, sir.
So
Yes.
the one MCQ is coming from this portion. That may be on the drift velocity, that may be on the electric, or that may, current, or that may be on the charge quantization. It's fine.
Yes.
Now, coming toward the second portion now. The second portion is potential difference. Now, what is potential difference?
Potential difference is voltage.
Yeah, but
Uh,
that definition,
Energy transfer per unit charge.
that's good, that's good. It is written as work done per unit charge or energy transfer per unit charge. That's good. So both definition can be used, that work done per unit charge between 2 points. Okay.
Yes.
So between 2 points, or energy transferred per unit charge for per unit, sorry, per unit charge, I have missed in about definition. Per unit charge for component. You can also write that, okay, for component. That's fine. The
Yes.
formula is V is equal to W by Q. This is very important formula, okay? V is equal to W by Q. It's fine.
We.
So
Yes.
what is V? V is the potential
Sorry, V
difference.
or W?
Sorry?
Sorry, never mind. V is voltage.
Yeah, V is voltage, W is work, and Q is charge. You can also write V is equal to E by Q. You can also write that. What is E? But mostly in the CIE, when they written E, they have written here the EMF. Okay? They have written
Yeah.
the EMF here. So I'm going to explain you EMF, but first we will discuss the unit. What is the unit? Unit is volt.
Voltage.
Yeah, can you hold for a minute? Can you hold for a minute?
Okay, sir.
Sorry, Ibrahim. So that's the call was a person. Okay. Yeah. So yeah, Ibrahim, are you there?
Yes, sir. Yes, sir.
Okay. So the unit is volt. Okay. Listen carefully. Okay. Now the MCQs are coming. Volt is equal to joule per coulomb. This is also coming as a first MCQ. First MCQ. Okay.
Yes.
You
Yes.
know that joule is equal to kg meter square. Sorry. Yeah, meter square per second square. And you know that coulomb is equal to ampere second. So, okay. So
Yes.
if you add it, the volt will be equal to kg meter square per second cube per ampere. And this is the MCQ also coming into the paper, okay? And this question is also come into paper 2 first question, your first question that prove the volt in the base units. Yeah.
Sir, for joules, what's the formula which we got? kgm squared s to the power minus 2.
Anyone, any formula you like, any formula.
Um,
You can use the work, you can use a kinetic energy, you can use a potential energy, any formula of energy that you like.
force
Yeah.
times distance.
Force time distance. Yeah. What is the unit of force?
Force for unit for force kg m to the power minus 2.
Yeah. Yeah, that's fine. That's fine.
Then
So so
acceleration is s to the power minus 2. So then we combine for
yeah.
force.
Yeah, that's good. That's good. That's good. So have you got it? Have you got
Yes, sir.
it? How you got? So basically, joule can be written in the Newton meter, and then Newton, as you know, that kg meter per second square, and it come out to be kg meter square per second square. It's fine. Now,
Yes.
okay. So coming back to the topic, so voltage is equal to W by Q. What is EMF now? What is EMF?
The cell, the battery,
Yeah, that is a source.
the source. Yeah.
And the definition we have written that energy transferred in AS, the definition is different, where A2, in A2, its definition is different, okay? In A2,
Um,
remember that. So in AS definition, accordingly, energy transfer per unit charge for whole circuit. It's fine. And the formula that is already I written, E is equal to divide by Q, and its unit is also volt. Its unit is also volt. It's fine now.
yes. Yeah.
Now, now, have you got it that potential difference and EMF?
Yes.
Okay. Now, let's come to very important law. And you know that law, Ohm's law. You know the Ohm's law.
Yes, sir.
Okay, can you say me, can you tell me the statement of Ohm's law?
Ohm's law states current is directly proportional to voltage
Current
with
is directly proportional to, okay, don't use the word voltage, okay? Use the word potential difference, okay?
yes.
So current is directly proportional to potential difference and when
Um, when the temperature remains constant or conductor temperature.
temperature and physical conditions. Physical conditions means resistance, pressure, anything will remains constant. It's fine.
Yeah, sir. This Ohm's law follows when the resistance is constant, right?
Exactly. So Ohm's
So
law
what if
follows when the resistance is constant and the temperature is constant. Yeah. Mostly in our
so
courses.
what if the resistance is not constant? Then what's the relationship?
Then the Ohm's law will not be obeyed. Then we will going to discuss it now. Like we have the two type of substance. One is called ohmic, other one is called non-ohmic.
Yes.
So the what is ohmic? The ohmic is that when you draw the graph V and I, That substance will give you the straight line. Okay, that's fine. This is the
Yes.
ohmic substance. Can you tell me that? Can you tell me that what the gradient of this graph give us? Gradient of this ohmic substance graph.
The resistance.
Okay, let's check. Let's check. Gradient. What is gradient? Rise over run.
Run.
The del I over del V. But it give us 1 over R, not resistance. Have you seen that?
Oh,
This is the misconception always the students have. Okay. This graph give us the conductance, which is always gives in examination. And the conductance is reciprocal of resistance. Remember that. Okay.
sir, what does the gradient give? The conductance?
Conductance. Okay. I will write again. That's the cutting is there. So I'm going to write again. So that
So, sir,
conduct,
what does that mean?
sorry,
What does that mean?
means that how perfectly the charge flow through the conductor without resistance. Without resistance, how perfectly the charge will flow. Yeah.
Oh, okay.
Okay. Like the conductor have high conductance. The question is not coming on the conductance, okay, in your paper, but that's only I'm talking about the graph and the low resistance. But in this graph, the conductance is constant, okay, because that's the gradient of slope. The conductance is constant and the resistance is also constant. It's fine. Yeah.
Yes.
Okay. Now, non-ohmic substance. There are three substances in your courses which are non-ohmic. Have you know that?
Mm-hmm.
What are
Yeah.
those?
Filament lamp, diode, and thermistor.
Exactly. So one is the filament and the filament graph is like that. This is filament. It's correct.
Yeah. Yes.
Okay. And the next graph, I'm making the same in the same way. So this is thermistor. Sorry, just a little bit sweeper. Let me make again. Now it's fine. So this is the thermistor. It's fine.
Yep.
And the last one is
Diode.
the diode. And you remember that the filament is conductor where the thermistor and the diode is semiconductor. Okay. Yeah.
Sorry, sir. I didn't get that.
Let me draw the graph. Then I'm going to explain it to you. So this is the graph for the diode. Okay. This is for the diode. It's fine.
Yeah.
You draw it, then I'm going to explain that thing I'm explaining you. Okay. Then I'm going to explain. Yeah.
Yeah, sir. What do I draw?
No, no. Have you completed? Have you write it?
Yeah. Yes, I took the screenshot.
Okay. So can I erase it?
Yes, sir.
Okay. Now I'm telling you that filament filament of bulb is conductor. Okay. And for conductors, when the temperature increases, resistance is also increases. Remember that, okay? For the conductors. And resistance is directly proportional to voltage, so that's why the voltage is also increases. But resistance is inversely proportional to current, so that's why current is decreases. It's fine.
Yes. Yes.
So, if the temperature decreases, then the resistance decreases. If the resistance decreases, the voltage across that resistance well decreases, and the current through that resistance will be increases. It's fine. This is the behavior in
Yeah.
conductor. Okay. This is the behavior in conductors. Now, if we consider the semiconductor like thermistor and diode. Now, what happens? When the temperature increases, the resistance will decreases. When the resistance decreases, the voltage across that resistance decreases and the current will increases. It's fine.
Yes.
Okay. Similarly, if the temperature decreases, the resistance well increases and the voltage across that resistance well increases where the current well going to decreases. And this is the behavior for thermistor. It's fine.
Yes.
Okay, now coming toward the third equipment, which is diode. What is diode? Do you know what is diode?
It allows current to pass through one direction.
Yeah, exactly. Diode is a semiconductor device. It's working as a rectifier and switch. Okay, and it only flow the current in one direction. So, do you know what do you mean by rectifier? Rectifier
Um,
to convert AC
or to
into
DC.
DC. Yeah, that's the meaning of rectifier. Okay, that's fine.
Yeah.
Now, now, have you seen? This is the behind science of the ohms. Do you know the symbol of diode?
Yeah.
So this is the symbol of diode. I think this is P and this is N. Or I am wrong. Okay, sorry, I am wrong. This is N and this is P. I think that's correct. It's fine.
Yeah.
Okay. Now, now coming toward another important definition, that was the power. What is power? Then after power, we will move toward the resistance. Okay. What is power?
Current times time. Sorry.
Okay.
Current times voltage.
Rate of doing work. Rate of doing work is called power. So the basic definition is remain the same. Okay.
Yeah.
So the power is equal to work done per unit time. This is the first equation. But we know that V is equal to W by Q or W is equal to V into Q. So put it here. So we get power is equal to V Q by T. And we know that I is equal to Q over T. So that's why the power will be equal to VI. As you told me that the power is a product of voltage into current. It's fine.
Yes. Yes.
Now, now if we put Ohm's law, V is equal to IR, then the power will come out to be I square R. It's fine.
Yeah.
And this is known as power dissipation formula.
Yes.
This is mostly used in the paper too when the word of power dissipations come. But when you put I is equal to V over R, so the power formula will come out to be V square over R. This formula is not used so regularly. Okay. What is the
Yes.
unit of power?
Watts.
So the unit of power is watts. Watts is equal to joule second, joule per second. according to main equation. What is the subunit of power? That is kg meter square per second cube. That's fine.
Yeah.
Okay, so this is coming into the MCQ. Okay, so that
Yeah.
unit of power is kg meter square per second cube. Watt can also be written as volt ampere. Okay, volt ampere. Yeah. Okay.
Yeah.
Now coming toward the another definition which is connected with the power, that is electrical energy.
Yeah.
So as you
EIT.
know that, yeah, exactly. As you know that power can be also written as energy divided by time, or energy is equal to P into time. We know that P is equal to VI. So if we put here, energy come out to be VIT. It's fine.
Yep.
Again, if you put Ohm's law, V is equal to IR, so the energy formula will come out to be I square RT. And this energy formula is known as energy
Power.
dissipation formula.
Yeah.
Energy dissipation. And another formula can be possible but not regularly used, that is Vi is equal to V over R, and the energy formula is V square over R into T. That's fine. Now coming
Yeah.
toward the electrical unit of energy. So as we know that power has watt, and watt is equal to joule per second. So joule will be equal to watt second. It's fine.
Yes.
But the electrical equipments are used in kilowatt hours. So the electrical units are used in kilowatt hour because watt second is a very small unit. So we know that kilo is equal to 1000 watt and hour is equal to 3600 second. So that's why kilowatt hour will be equal to 3.6 into 10 raised to power 6 joule. Or we can write kilowatt hour will be equal to 3.6 megajoule. Yeah, this is
Yeah.
the proof, show that comes into the paper too. Yeah, that's fine.
Yep. Joule is equal to watts times seconds.
Yeah. So, any question in this sheet? Yeah.
Um, Sir, watt is 1000?
No, kilowatt is 1000. Watt is very small unit.
Yeah,
Watt
okay.
is a small unit, okay?
Ah, okay, okay.
So that's why we using kilowatt, that is 10 raised to power 3 watt, or megawatt, that is 10 raised to power 6 watt. Mostly given in your questions also. Yeah.
Okay, sir.
Any other question?
No.
Okay. Now we are going toward very important quantity, and this is the, you can say, heart of the electricity, that is resistance. Okay. Now we are going
Yes.
to discuss the resistance, and next the difficult question is coming on the resistance. Now, have you taken the screenshot of this?
Yes.
That okay. Now, resistance. The first question arises: what is resistance? Can you define resistance?
Resistance.
Is the
Uh,
process in which he
mm,
opposes the flow
Voltage
of
required to.
current. No, no, opposes the flow of current. The simple definition, or charges. It's fine. Opposes
Yeah.
the flow of current or charges. The device which is used as a resistance is known as resistor. It's fine.
Yeah.
Now, factor on which the resistance depend. Factor depends. Number one, resistance is proportional to length. Number two, resistance is inversely proportional to area. Number three, resistance is proportional to nature of material, resistivity. Resistivity, okay?
Yeah.
That is nature of material. And number fourth, we have already discussed that resistance is proportional to temperature in conductor and in resistance is inversely proportional to temperature in semiconductor. That we have already discussed.
Sir, the filament lamp was conductor, right?
Exactly. And the thermistor is semiconductor. Yeah.
And
And
the
I
diode as well.
also semiconductor. But because the diode is not temperature dependent, thermistor is only the temperature dependent. Yeah.
Yeah, okay.
Okay. Now coming toward the formula of resistance. If we combine these three relations, these three, so we get resistance is equal to rho L over A.
Mm.
This is the one shape of formula. Another shape. Resistance can be written as rho L over pi R square. This is the another shape of formula. And you can write with another shape that resistance is rho L over pi D square by 4. This is the another shape of formula which can be used in your MCQs, especially questions. Okay. Yeah.
Yes.
Now, another thing, very important hint with reference to the MCQ. Okay. If in MCQ, they says length becomes twice. If they use the word length become twice. And before this wording or after this wording, they use the word of a stretch, stretched. So remember that the area becomes half. Yeah. Have you understand it?
Yeah, so whenever
Whenever they
you
use the word stretch and they say length becomes double. So they will not mention you that the area is half. You have to know that the area is half now because they have stretched the wire. Yeah.
yeah, oh, okay.
Have you understand that?
Yes.
And how you going to verify your answer? If this is the situation come, your resistance will be increased 4 times. Remember that. If this is the situations come, your resistance will be increased 4 times. Yeah,
Yeah, okay, sir.
it's fine. So this is the one hint. Another hint. If they say radius is half, now what they says radius is half, but they use the word of stretch again. So remember that your length will be increased 4 times. Remember that. If they say radius is half or diameter is half, they can also use the word diameter. Okay. Diameter is half. So remember that, and the next they use the word stretch, then your length will be increased 4 times. Yeah.
Yeah, okay.
And how I know that? How I know that? Because I know that area is pi r square. Our area is pi d square by 4 because the square term is there. So that's why it becomes 4 times. Okay, that's fine.
Mm, yes. Yeah.
Now, in this case, your resistance, how to verify your answer? Your resistance will increase 16 times. in this specific case. Your resistance will be increased 16 times. Remember,
Okay.
okay, it's fine.
Yeah.
Now there is another thing. Now there is another thing. I have seen the question last time. I'm doing the question on the student that if the resistance is constant, now in the question they have mentioned, and they says resistivity is same, means resistivity is also constant. Then your length and area is proportional to each other. Remember, or your length and radius is proportional to each other, or your length and diameter is proportional to each other. Yeah, that I seen the question that written with P and Q. That P is Q and there, and they say their resistance is same, resistivity of P and Q is same. So if the diameter becomes half, what happened to the length? Okay. So this type of
Yeah.
question is coming, I have seen in the MCQ. Okay. So remember
Mm,
that. So when this is when the resistance is constant. Okay. When the
yes.
resistance is constant, then this. If you remember these hints, you can never ever your question never ever becomes wrong. Okay. If you
Yes.
remember these hints, your question will be always correct. It's fine.
Yes.
Okay. Now let's consider the another equipment. You know that equipment, but let's discuss LDR. Do you know LDR?
Yes. Light dependent resistor.
Exactly. Light dependent resistance. Now, that's very simple concept is there. If the intensity, this is also semiconductor, okay? Remember that.
Yeah.
This is also
Yeah.
semiconductor. So if the intensity of light increases, your resistance will decreases. Your voltage will decreases, but your current is going to increases. That's fine.
Yeah.
If your intensity of light decreases, like night, in night time, your resistance is going to increases, your voltage is going to increases, but your current is going to drop. And this LDR is used in the automatic street lights, okay? Street lights as a switch in street lights. Okay?
Yes.
No. With this, your 3 units are finished now. With 3 units, okay? Now we
Yes.
coming toward the DC circuits, which is the most important. How is your circuits chapter? How was your circuit chapter?
Uh,
It's good or it's partially good?
I think so. It's partially good.
Okay, let's do it. Take the screenshot and then we move toward the DC circuits.
Yes, sir. Uh, sir, if you can move.
Can I remove it?
Yes, please.
Okay. Now, DC circuit. So start from the simple concept. Okay. There are two types of circuits. One is called series circuit. Do you know the properties of series circuit?
Mm,
Series circuit is also known as potential divider circuit. Remember that. Okay.
yep.
In this circuit, current remains same because there is only single path. Potential is divided. Potential is divided across each resistance. It's fine.
Yes.
And for the total resistance, you will use the formula R is equal to R1 plus R2. So you simply add the resistance and you get the answer. It's fine.
Yes. Yes.
Second type of resistance is parallel resistance, a parallel circuit. Sorry. Second type of circuit is known as parallel circuit. The parallel circuit can also called current divider circuit. Current divider circuit. So in this circuit, the current is divided through each resistance, where the potential remains the same. Potential remains same across each resistance. It's fine.
Yes.
So the potential remains same across each resistance, and if we want to find out net resistance, we will use the formula 1 over R is equal to 1 over R1 plus 1 over R2. It's fine.
Yes.
Okay. Another hint, I just tried to forget that here the total resistance is less than, no, sorry, greater than individual resistance. The total resistance will be greater than individual resistance. But in parallel, the total resistance is less than individual resistance. So if you want to decrease your resistance, you connect the resistance in parallel. Okay, parallel form. It's fine. If you want to decrease the resistance. Yeah.
Yes.
Now there is another concept with the same circuit diagram, that is internal resistance. Do you know what do we mean by internal resistance?
Resistance in the cell.
Yeah, the resistance in EMF means in the source. Okay, let's draw the circuit, a simple circuit. For example, this is a battery, and this is the internal resistance of the battery, and then we have the external resistance. It's fine. Now, how I know that this is the internal resistance? So during in the exam paper, they make a box around it. Okay. So it means
Yeah.
this is the internal resistance. So this is positive terminal, this is negative, and this is called EMF. This is internal resistance and this is external resistance, because the internal and the external resistance are connected in series. If you see, they are connected in series.
Yes.
So that's why you can write the formula EMF is equal to I R plus R. Or you can write EMF is equal to IR plus IR, where this greater I or drop can be written with potential difference V plus IR. Now, what is the meaning of this equation? The meaning of this equation that EMF is always greater than voltage. Fine. Can it be possible that EMF can be equal to voltage? Yes. If the current through the circuit is zero, which is the open circuit, means switch is off, then EMF will be equal to voltage. It's fine. Only
Yes.
that case when the EMF and the voltage is equal. It's fine now.
Yes.
Now let's discuss the combinations of some question, okay? In series and parallel. One of the question that I have remembered it. So let me draw that question. For example, this is this is the question that I have taken from the MCQ paper, okay? From the MCQ paper. Here we have the thermistor. This is the thermistor. And here we have the LDR. It's fine. Now this is the LDR. Yeah. This is in the question that when we move from day to night, day to night, the temperatures changing from, for example, the temperatures changing from cold to hot. Have you observed the question?
Yeah.
Yeah, they have changed the question. Okay. So they says we are moving from day to night. So the temperature is changing from cold to hot. Now what happen? What happens? The voltages, the potential differences of LDR and thermistor. Yeah, yeah.
Okay. So for the thermistor, the temperature increases, so the resistance decreases, the current increases, and
The potential difference
the potential difference decreases.
decreases. Okay. And what about the
The LDR, so resistance increases, potential difference increases, current decreases.
in LDR? They are moving from day to night. Okay, let's move from night to day. Okay, let's make it little bit real. Day, night to day, night to day.
So yeah, night to day,
Yeah,
night to day for LDR. So
yeah. No,
night to
it's
day, resistance decreases,
yeah,
current increases,
yeah.
and potential difference decreases.
Decreases. Okay, so the potential difference is also decreases because the resistance is decreases. That's fine. That's
Yes.
fine now. And similarly, if the questions come on the internal resistance, like there says there may be a many questions on the in the paper 2 is coming on the internal resistance, okay, but one of the question I am writing here, okay. Okay, so this is, for example, so for example this is our EMF and that is 9 volt. This is the internal resistance and this is the basically resistance with 100 ohm. And this is another resistance with the 50 ohms. You have to calculate the resistance of small r. How are you going to calculate the small r?
So where's the small?
Internal resistance. Sorry, I haven't made the box. Let me make the box. So this is the internal resistance. Yeah.
Smaller. Okay, so
And for example, if I give you another thing that they have given the current to you, there's 1 ampere. Yeah. And this is a 1 mark question, okay? Not 2 mark question.
yeah. Okay, sir. So we will do. Sir, should I calculate it for you or what?
Yeah, yeah, you will calculate it. You can tell me only what will be the answer
We'll do.
can be possible. Yeah.
Wait, sir. Let me think.
Which formula you will use? You can tell me that.
Yeah. We will do EMF minus voltage.
Sorry?
EMF minus voltage, or the external voltage.
Okay, okay, okay. You do it. How you get the answer?
So EMF is 90.
Mhm.
EMF is 90.
That's 9, not 90, 9 volt. Okay.
Oh, 9. Okay, sorry. 9. Sir, let me calculate.
Yeah.
150. Sir, I'm getting a negative answer.
Yeah, maybe possible my values are not correct, but which formula you have
And
used? Can you tell
so
me?
I did um uh, voltage is equal to EMF minus internal resistance.
Okay, can I write the formula? Then you can verify it as you use the same formula or not. Okay.
Yes, sir. Yes.
Okay. So I will use the formula EMF will be equal to I R plus R plus R. Yeah. That will be 9. That will be 1. That will be 100. That will be 50. And this will be plus R. So I know the answer will be in minus because my values are not correct. So,
Sir,
but
I got negative 141.
yeah, yeah, definitely, definitely. So values are not correct. So that's fine. That's fine. Okay,
Uh,
it's fine.
so I did yeah, I used the same formula. V is equal to
Yeah,
EMF
you
minus I.
that's fine. That's fine. You use with the minus sign. You use with the minus sign. Okay, so that's fine. That's fine. That's fine. Okay. Have you noted
Um,
that all things?
mm, take a
Okay.
screenshot.
Okay. Take the screenshot.
Yeah, done.
Okay. Now we are moved
Done.
toward our second last topic, that is Kirchhoff law. Kirchhoff. Do you know Kirchhoff?
Kirchhoff law, yeah.
Yeah.
Mm.
So Kirchhoff's law. So Kirchhoff's law is applied only on the complex circuit. Okay.
Yes.
Complex circuit. What is complex circuit? Complex circuit means that circuit which has more than one EMF and many paths. It's fine. That is called complex circuit. There are two laws of
Yes.
the Kirchhoff. The first one is known as first law, or it is called KCL. KCL means Kirchhoff current law. So MCQ, kindly note the MCQ. Kirchhoff current law obey conservation of charges. Conservation of charge. Okay. This is the MCQ
Yes.
coming into the paper. Okay. Now the Kirchhoff law statement. It's a state that sum of all currents is zero. So this is the one statement which is can be written as summation I will be equal to zero. It's fine.
Yes.
Okay. Another statement is that that is mostly written in the Cambridge marking scheme that uh, total current enter into the junction is equal to total means sum, okay, total current leaving the junction. It's fine.
Yes.
And mathematically it can be written as summation. Do you know the sign of
Uh,
summation?
Come on.
You have the mathematics.
Yes, sir. I take maths.
Okay, so you know that is the summation
Yeah.
enter is equal to summation leaving. That's fine. So current
Yeah.
leaving, not summation leaving, current leaving. Let's take the example. For example, okay, the junction. What is junction? So for example, this is a point. This is a current coming into the junction. That is I1. And the junction is that point where the path is going to divide it. So that is the leaving the current. So what will be the Kirchhoff law? That I1 will be equal to I2 plus I3. So this will be the Kirchhoff law. That's fine.
Yes.
Now this is
Yeah.
Kirchhoff first law. This is Kirchhoff first law. Now the Kirchhoff second law. Second law. What is second law? That is KVL. Kirchhoff, do you know KVL? Kirchhoff voltage
Sorry.
law. Yeah, KVL means Kirchhoff voltage law. That's fine.
Yeah.
Okay, it's the MCQ. It's obey the conservation of energy. Conservation of energy means total energy remains conserved, remain constant. Okay. According to its statement that sum of all potential difference and EMFs is equal to zero.
So, Kirchhoff's first minimum.
Sorry, can you repeat again?
Sorry, sir. I was gonna ask both of the Kirchhoff law obeys conservation of energy, right?
No, the first law only obey the conservation of charge, and the second law obey the conservation of energy. Yeah, yeah.
Because okay, yeah, the Kirchhoff second law we're talking about potential difference, not current.
No, they are not talking about current. They will talk about the potential difference. Yes.
Yeah.
And this is the
Yes.
MCQ, regular MCQ coming into the paper. If Kirchhoff first law obey and the second law obey. Okay. So first law obey conservation of charges and the second law obey conservation of energy. Yeah, it's fine.
Sum of the EMF is equal to sum of individual PDs.
Yeah. And this is the formula. This is the formula we using for the Kirchhoff second law. Now, if you remember the rules of Kirchhoff second law, rules, there are some rules. If you remember those rules, so that law is very easy for you. Okay? Do you know the rules?
The rules
How
of
applying the Kirchhoff law?
mm, I think yes, sir.
Okay, let's discuss and then you will let me know that how many rules do you know and how many rules you found new today. Okay,
Okay,
that's
sir.
fine. So let's see. Okay, so this is our EMF 1. This is my EMF 2. And this is my resistance 1. And this is my resistance 2. Now, the first question, which EMF I will, which, according to which EMF I will take the direction of current? Yeah,
The direction of the current.
according to which EMF? EMF 1 or EMF 2?
Sir, EMF one and EMF two, we will take from positive to negative.
But they will cross each other. So
Yes.
which EMF you will take it? You will take the direction of circuit current. So according to which EMF? So the rule is that which EMF is greater, you will take the current of that EMF. Okay. Now which EMF is greater? Like as I mentioned that EMF 1 is greater.
So why is EMF one greater?
No, that's my consideration. In the question, they will mention. In the question, they will give
Oh,
you that which EMF is greater. Okay. Like in one question, I have seen they given the 24 and 6 value. So definitely you will take the direction of 24 EMF. Okay. It's fine.
mm.
So, so then what is the second EMF will be doing here? So second EMF is used as a capacitor. It's only charging itself. It's fine.
What is the capacitor doing?
Yeah, the capacitor is basically not in our course, but the capacitor is a safety device which store the charges, okay? Which store the energy, sorry, which store the energy. Okay, it's fine.
Yeah, okay.
So it is not in our course, but in one paper I have seen they asked that what the second battery will do. So you will write the second battery will store the energy coming to it. Okay, that's fine. So that is the first
Uh,
rule. Yeah.
okay.
The second rule, you will mark the circuit current according to EMF. Now you will take the loop current. And this is a possibility that the loop current must be in the direction of circuit current. This is my loop current. It's fine.
Yes.
Now, the third point, I think you know the third point. If the loop current is moving from negative to positive, then the EMF will be taken as positive. It's fine. But if the loop current is moving
Yes,
from
sir. This
pos,
but
sorry,
positive. In our case, it's positive to negative, right?
exactly.
I will take E. Which E one or E two?
E1 is positive because the loop is current is moving from negative to positive, and E2 is negative because it is moving from positive to negative. Yeah.
Okay, sir.
So this is called rises and this is called fall. Okay, falling or fall. So that's why it is negative. Okay. The
Yes.
last point, if the loop current, loop and circuit current, there are two currents, okay? One is a loop current, another one is a circuit current, or in same direction,
Yes.
in same direction, then IR will be negative, okay? If it is opposite direction, then IR should be positive. Yeah. In this case, in my circuit
Sir, can you
diagram, yeah, if the loop current and the circuit current, the current which I have made the direction with the green line and the circuit direction which I have made with the blue line, if they are in the same direction, so then the I or voltage means voltage will be written as negative. If these I are means the loop current and the circuit current has opposite direction, then the IR will be written with positive. Okay. Yeah.
okay, sir. Sir, when you drew the loop current, how did you draw the loop current?
Yeah. The Kirchhoff suggests that you will
For
take
part
the
two.
loop current in the same direction of the circuit current. That is the suggestion of the Kirchhoff, that you will take the same direction of the loop current, that is the of the circuit current, in the direction of the circuit current. Yeah.
Yes, sir. In that case, the blue and the green will always be the same.
No, that's not important. In this time, I have taken the single path. But when there are two paths, the Kirchhoff says for the two path, the loop direction must be synchronized, means they will be in the same direction. Then you will see the positive and the negative sign. Yeah. If there are more than one
Okay,
path.
sir.
Yeah. Okay. Now, with this, these
Yes.
are the points, and then you at the end you will write the equation. Now, the equation will be now EMF1 minus EMF2 minus IR1 minus IR2, and that will be equal to 0. That's fine.
Yes.
So with the help of Kirchhoff law, I write all the values from that circuit. Okay, by applying the Kirchhoff law. Yeah.
Yes.
Okay. Now with this, your Kirchhoff law is going to complete. Yeah. Yeah. Any question? Yeah.
No, sir.
Okay. So let's come to let's can you take the screenshot now?
Yes, sir. I've taken it.
Okay. So the now we have the last chapter, that is potential divider. Potential divider. You know that as I told you, the series circuit is also called potential divider. Okay. So let's discuss
Yep.
the equation of potential divider. First, I will make the simple circuit and then toward the paper question. Okay. For example, we have the two resistance here, and this is our input. This is our EMF or input voltage. You can call them input voltage. This is my resistance 1, this is my resistance 2. And this says find the voltage, output voltage across the resistance 1. Yeah. How you will write the formula? So output voltage will be equal to input voltage of R1 divided by total resistance. It's fine.
Yes.
Okay. So the similarly, if this says R2, you will replace only R1 with the R2. Okay. This is a simple formula you will use.
Yes.
But in the paper, the question will not coming like that. The question will be coming like that they give you the internal voltage and then they will give you the a very large resistance. They will give you a very large resistance, that is Q and P. And now from here another point will come to join this point, that is R. And then they says find the output voltage for this point. Yeah, it's fine now. So how you will write the equation for it?
Yes,
You will
sir.
write V naught is equal to Vn. So you will find the resistance of PR divided by PQ. So with the help of this formula, you can find the output voltage across the resistance. It's fine.
Okay. Yes.
But the major question is not coming from the potential divider. Major question is coming from the potentiometer. Do you know potentiometer?
Potentiometer.
The
No, sir.
practical that is also involved in the practical examination in paper 3, okay? The potentiometer is the device which used to measure voltage or potential difference across wire, okay, or
Yeah.
to find unknown resistance, unknown EMF, sorry, unknown EMFs. The accuracy of potential difference depends upon the length of wire. It's fine.
Yeah.
And the last point, theoretical point, that the principle on which its work is called balancing point. Balancing point or null point, okay, in the galvanometer. In galvanometer. Do you know what is galvanometer?
Yeah.
Galvanometer is the device which used to measure the current, small current, or to detect the current. Okay.
Yes.
Okay. Now, so let me, what is null point means? Null point means when the galvanometer show the zero reading. Okay. That is point is called null point. Okay. Two type of
Yes.
questions is coming on these potentiometer. So I'm going to draw the potentiometer. Okay. Now, so the first question which is coming regularly into the paper, that is they give you the wire. This is for example the wire A and B. It's fine. And
Yeah.
there a battery connected with this wire here. And this is the source battery, okay? Source EMF. If I call them EX, this is a source EMF, okay? The second EMF will be connected here it is a sync EMF, and then it is connected with the galvanometer, and then it is connected with the jockey. It's fine. Do you know jockey?
Jockey?
Jockey. Have
No,
you
sir.
heard about it? So jockey is the basically this point. Jockey just like uh, you can say just like a marker which is used for the sliding connection. Okay,
Yeah.
sliding connection. Now remember that what is first condition? Okay, very important condition. This is the MCQ also coming. Remember always source EMF is always greater than the other EMF, okay? Other EMFs. Otherwise, your potentiometer will not work, okay?
Yes.
Okay, now the first question which is coming on it. Now, the source EMF is for the whole length, means the length from A to B. That's fine.
Yeah.
And the next EMF is only for the length between A and C. So this is the
Yeah.
one formula you will use in the potentiometer question. Yeah.
Yeah.
Okay. There is another question coming on the potentiometer with slightly different picture. Like the wire is there. Okay. The same wire. Like the source battery is there according to the above diagram. But with the slight different picture is that there will be no second battery. The two resistance will be there. For example, this is the resistance P and this is the resistance Q. It's fine.
Yeah.
And the galvanometer will be connected at the middle and then it is connected with the jockey. Jockey on the wire. Yeah, it's fine.
Yeah.
Now, how you will going to write the formula for such a circuit? Now, the whole length, which is AB, is for the total resistance. Total resistance is P plus Q. And the small length, sorry, just a minute. Uh, that is the whole length is for the total resistance that is P plus Q. And the small length AC is for the only resistance P. It's fine. And you get the formula.
Yeah.
For the null reading, kindly note that for the null reading means for the 0.0 point searching on galvanometer, move the slider, means jockey, okay,
Yeah.
toward left, not toward right, okay, toward left. Because this is the MCQ come into the recent paper. So there says toward right or toward left. So remember that when you are moving toward left, then you will find the 0 point, okay, null point. It's fine.
Yes.
Because when you move toward the B point, the length is going to increase. And when the length is going to increase, so it will not give you the 0 point. Okay? Yeah.
Yeah.
So with this, your whole chapter, whole electricity is finished. Yeah, Ibrahim.
Yes.
Okay. But remember that I have done the course only. There are many questions which is coming in the papers. And if you do that question, then there is a benefit of course to you. Okay.
Yes.
Otherwise, if you are not practicing the question, the only that thing that course is not any benefit given any kind of benefit to you. Okay.